Okay, so shall we start? And let us welcome Martin Grandjean. Bonjour, Martin. Martin is a notable researcher in the field of network analysis, and I'm not afraid to say it, one of the pillars of the network analysis community in the DHREAL. And for me personally, Martin's blog was one of the first encounters with network analysis, and I remember how I was impressed with all the visualizations that I saw back then. And today, Martin is going to give us a talk entitled Beyond Visualization, Main Challenges of Network Analysis in the Humanities. So in Russian it will be «За пределами визуализации. Основные проблемы сетевого анализа в гуманитарных науках». So Martin, please, the floor is yours. And we have about an hour or so, so you can take the time. And if you wish to spare some time for the questions, I think it would be lovely.
Excellent. Thank you so much for your introduction, and thank you so much for having me today in Krasnoyarsk. I would be delighted to visit Krasnoyarsk once, and of course that's a pity not to be able to meet you all and to see your faces and to be able to discuss your own projects and questions, and that would have been really nice. But anyway, we know the situation we are in these days and these years, in fact, and that's all we do nowadays. And I'm happy to be able to share
in the future.
Yeah. Anyway, that we have ways to share together today. I hope your day was interesting, and I hope your the EADH conference will be as well for you in Krasnoyarsk, even if not everybody is coming to your city. As you said, and that's a very nice introduction point for this talk. You were speaking about the impressions you had when looking at visualizations on my blog or somewhere else anyway, and that's really something that is interesting about the use of network analysis in the humanities and in the digital humanities in general, which is the fact that we very often produce visual elements that are in a certain way impressive, or not that they are necessarily meant to be impressive, but they do impress people that are not used to this kind of visual narratives and visual expression of the data. And so my talk today will be about how do we use this visualization to go, I would say, beyond itself or beyond the visualization. Of course, that's a bit ambitious, because in a certain way we are also in the humanities working with images and pictures in general. So that means that analyzing pictures is also part of our job, but to try to play with these pictures and these images extracted from the data to get new information on our subject. I will divide this presentation into three parts, especially first a kind of introduction on what network analysis is, and especially with a focus on what does that means to study a structure, the structure of something, of a subject. That could be an historical subject, a literary subject, any possible subject or object we do have in the humanities. What does that means to analyze it as a structure? And especially an important point in my view is the fact that network analysis gives a lot of context around a specific information. It gives a structural context around it. The next point will be the main point about using metrics and what's the relations between these metrics and our interpretation we will do on the network analysis. Especially because basically network analysis is mostly something mathematical, and it is being translated into a picture, and most of the time we do see the picture more than the numbers that are behind the data that are behind. But that's interesting to make this not necessarily distinction, but at least to understand very well what we are doing when we are visualizing something. We are expressing the data and coming back to the data and working with the metrics of graph theory is something that could be very, very interesting for the interpretation. Of course, this will also be a bit introductory, and all this talk will be in a certain way an introduction to that, because I will speak less than 1 hour, and I don't know you much more than just looking at your names on the screen, and I don't exactly know where you are into network analysis. So let's stay a bit general, and we can find other ways in the questions after, or maybe by email if you have more precise questions, and if you want to continue the discussion or other meetings, maybe. And the last part is about applying network analysis to the humanities specifically, and especially looking at the practices. What do people do when they use network analysis in the humanities? With a little case study, and but also with the time frame we have, some kind of trying to have the panorama, trying to have the overview of what is done in general when people are doing network analysis in the digital humanities. Let's say digital humanities, because that could be humanities in general, but more precisely here the context is digital humanities. So about this first part, studying relationships in their context, network is really all about giving context around a specific relation. We are always working on relations, and we could say networks are everywhere. Maybe this morning you took a bus from your home to the university, and even the bus city map is already a network, and you already need to have a network mind or a network thinking when you are thinking about the different steps you will need to go through to go from your home to the university, for example. So everything, we understand that very well. And if we look at social networks in general, in terms of social medias like Facebook, Twitter, and so the network is very visible, but in fact it's almost every subject can be translated into a network, and that's something that makes it very rich, but also a bit disturbing or difficult, because that means that we need to make to be very precise about what we do model as a network when we do formal analysis, because everything could enter it and mix your buses with your personal relations, and that's a network that is probably not understandable and that you cannot analyze precisely, because that's not at the same level. Just to start with a very little example on why is contextual and structural analysis interesting. In general, when we analyze the relationship between two people, we are very interested in what makes the relation between these two people. Let's say two people, but that can be two bus stops if you want, but peoples in general are. It's easier to relate to this kind of example. So let's say that here we have two peoples, and they are connected by relations. Like, let's say they are sharing, I don't know, friendship. So they are friends with each other. So we will formalize this relationship with these two dots connected by an edge, or dots or vertices or nodes by an edge. And what will be interesting to us, of course, is the relation between these two people. That's our subject. We let's say we are sociologists or we are historians of the relations between these two people, and we are really interested in this very little edge between these two nodes. But of course, if we want to give context to this relation and understand it better, it's very useful to know that these two people are also connected to other people. They don't just have one friend. They could have many different friends. And interestingly, these friends can have relations together as well. And it's interesting, of course, in a friendship group, in a group of friends, you will have this kind of relations occurring a lot. Because everybody will be friends with everybody. And they could also be friends with people that are not friends with the two persons that are interesting to us here. And of course, we can expand that, expand, and then have the network of all the friends in the world. That's not really what is interesting to us, but what is interesting to us here is to contextualize, or if we go very far, to hyper contextualize the relationship between these two people. And we are still interested in just this very simple edge here between these two vertices here between these two peoples, but knowing that they do have friends organized in a certain way around them will makes us interpret this relation differently. And here I present exactly the same number of people and the same number of friendship, but just in a different way to show you that this very single blue line here will be interpreted very differently if it occurs at the center of a quite dense group, or, for example, if it is the link between two different groups. I mean, this friendship is always exactly the same personal friendship between two people, but us as an observer, as an analyst, we will analyze it differently, because even if it contains exactly the same feelings and love or friendship, it will mean something differently socially, especially if it's between two groups like that, or if it's within a group, but we know that other groups are also formed that are not connected, or if this friendship appears in a social space where everybody has almost the same number of relations with all the others, and so a very harmonious world, I would say. So these are, of course, theoretical situations, but just to make you understand why a network analysis is interesting, it's to give the context around specific relations. And we'll always speak about relational data because that's really the basics of network analysis. So network analysis is a way to contextualize. And of course, with these very small examples here, I don't know exactly how many nodes I put on this graph, something like 20. This becomes more and more interesting when the network is bigger, of course. And if you analyze, I don't know, if you say that two dots are connected, if these two professors or two researchers did research together, and you were analyzing here research groups that are collaborating or not, it will be very interesting to map that at the level of the faculty, or to map that at the level of the university, or to map that at the level of your country. And just to make this zoom out and to try to understand the relations between all these researchers collaborating or not collaborating. So this is the graph of scientific collaborations in Switzerland during 10 years at the beginning of the 21st century. So that's the data from the Swiss National Funding Research Funding Agency. And here you have tens of thousands of researchers and tens of thousands of projects connecting these researchers. And of course, you are here in a situation where this hyper contextualization, this gigantic contextualization of maybe one single relation you want to analyze is way too big to be able to get back to these single relations. And you will need to have new tools to try to dig into this kind of enormous graph. So in general, these kind of graphs are not graphs that are made to be displayed and to be explained like that. You will not read them as a metro or a bus map. This is something you can't do here. But what is interesting is that graph theory will give us different tools to try to untangle this gigantic hairball. We call that a hairball, or a big spaghetti monster, you know, the plate of spaghetti with the bolognese and then little meatballs in the center and things like that. So that's something that cannot be read by the eye. So you need new tools and new ways to analyze it, especially in the humanities, because we're not used to read clusters, to read sparse area, to understand what's behind here, and most importantly, the network in itself is just a construction based on a data set. That's not I don't know, the reality of collaboration. That's just a specific type of collaboration, which is being together, PI on a project, or collaborators on a project. So that means that we'll need to analyze it with these eyes, knowing that the data set that is behind is just part of the reality, and that this visualization is just a data model. So to keep it critical, of course. Especially here, this network, I did this analysis a few years ago, and it's extremely hard to read it because you have like 50 different disciplines, and of course you will not find all the physicists here and all the medicine researchers here and all the humanities researchers here. Of course, interdisciplinarity is real, and you will find people everywhere, and that will make it very hard to read and to interpret. So we need other ways to analyze it. Despite the fact that, of course, this picture is a nice picture. It has been made to be nice. It has been one of the output of this picture a bit, and that's a bit funny, is that I just posted it online, and the director of the Swiss National Science Foundation used this picture on a PowerPoint slide during one of his presentations to show what the Swiss funding agency was funding. So that means that, as you said as an introduction, these pictures are fascinating. They are, we believe they are telling something. And that's interesting to see the reuse of this kind of visualization, and especially the fact that it is being used for something it has not been made for. So of course, let's come back to more simple situations. Network, you know probably more or less, if you're not completely into networks, what it is about: nodes and edges, connecting to these nodes together. You can have many different types of edges depending on the data model you are working with. That could be undirected edges and directed edges, which would be the most common type of formal relation you could have between nodes, but more exist as well. And the limit is just your imagination, of course, because depending on your subject, you may want to use other models. A few basics of terminology as well. We very often speak about connected graphs in general. The one I showed before was not a connected graph. Connected graph is a graph where every nodes are connected in a certain way to the main giant component of the graph. But in fact, in real life, graphs are not a connected graph. They are disconnected. They are composed by different groups that are not linked together. But very often in digital humanities paper, the researcher will focus on the main and the biggest hairball, and will probably be less interested in all the little other groups that are around. Just for you to realize that, and this will skew the statistics as when you analyze it, if you don't take that into account. In terms of vocabulary, we very often speak about bridges and clusters and cliques, and we'll come back later to vocabulary linked to the relation we make between the interpretation and the situation we observe in the network. And that's very interesting to see that we are giving natural language words to speak about, I don't know, a node that is bridging two clusters together. The bridge is a very understandable metaphor, but in fact, is that really what this node is doing? Is it really bridging, or depending on the data that is behind, maybe that's not a bridge, that's the last connection that will be lost in the next iteration of the graph, not necessarily the one that is making these parts coming together. We speak about one-mode network, two-mode networks. I'm making this difference here just because I observed that in the humanities we're very likely to work with two-mode networks, which is network on the right here, that are composed of two different types of nodes. Could be people and institutions, for examples, or airplanes and airports, and this kind of duality between two types of elements in the network we are studying is very common, even if in general we prefer to analyze one-mode networks. That means only network of people or only network of institutions. But in general, we start, even without knowing it, to build a two-mode network, and then in the end, we project it, we translate it into a one-mode network. So that's just for the basic introduction and terminology. And of course, all that leads to what makes graph theory interesting for the application of network analysis, the use of different metrics. And I will spend more time on the metrics just after, but but just to make you understand how these metrics works, if you never worked with the network analysis software, the graph metrics are a calculation of specific properties of certain nodes. And the one that is the easiest to understand is the degree centrality here, where you just count the number of nodes one single node is connected to. So you're just counting the neighbors of a specific element of the graph. And here, if you take this dot here, it has 1, 2, 3, 4 neighbors, which is a lot in this network, so that it will be black. This one has just one connection, it will be white. And this one highlighted here is the one that has the most connections and the most neighbor here. That's the basic degree centrality. The term centrality is interesting as well, because that means something to us, centrality, to be central, or in opposed to be peripheral in the graph. And what is interesting here is that this node that is supposed to be the most central in terms of degree centrality is not central at all in terms of the overall geography of the graph. It is completely at one end of the graph. So that means something about the names we give to this kind of metrics, and the interpretation that it will trigger after, and we need to be very careful about how we name things, and we see very well that the term centrality in general is a bit misleading, especially in the social and humanities, in the social sciences and humanities, because we put a very precise meaning behind what a centrality is. And you have many other different centralities. Betweenness centrality, which is the number of time a specific node is on the path between all the other nodes of the network, which means in a certain way the node that is bridging different part of the graph, as I said before. You can have closeness centrality, which is the closest to the metaphor of centrality, or the definition, the natural language definition of centrality. So that's the node that has the shortest distance to all the other nodes of the network. So that means that on average, it will be in the center, on the geographical center of the network, and so on. So we'll come back to the centralities, but I thought it was interesting to present them already here in this very short introduction. And what is interesting with all this calculation we make on the graph is that it informs us of specific patterns and specific regularities in the graph, but is not enough to understand everything. And that's why I'm playing in this little talk today between this with this title, Beyond Visualization, and to show here that in fact, even if when we are doing pure graph theory and network science in general, we want to rely only on metrics, but that's not always possible. Sometimes we need to come back to the visualization. If I take the example I showed before, what is very interesting in these examples is the fact that they share a lot of statistical properties. These 4 examples are what is called in statistics an Anscombe quartet. The Anscombe quartet is this famous example of these 4 different, very simple graphs that are very different if you look at the orange dots, but that are all exact. They do all have exactly the same tendency curve. So that means that if you analyze them only with this regression line, you will, and you don't visualize these 4 different data sets, you will have the same result, and you will maybe make an interpretation that say, okay, that is just a progression from this value to this value. This trend line is always the same. But then if you visualize them, you realize that they do look very differently. And in our case, all these networks from this first examples, they do have the same number of nodes, they do have the same number of edges, they do have the same density, they have the same degree distribution. So that means that every in all of these 4 little examples, you will have 1 node that has 8 connections, 2 nodes that have 7 connections, and so on. So that means that even if we in general say that we should not rely on visualization, that also means that sometimes we should not rely only on metrics as well. And life is not always black and white, you know, that we need to use the tools at our disposal, and visualization is also one of these tools. We need to use that and not to rely only on graph metrics. Let's go to the second part of this presentation, which is the formalization of network analysis, to speak a bit about the history of these metrics and how do we use them in our interpretation of our network. This is a very famous example, and this is considered to be the first occurrence of the application of graph theory, or not necessarily the application of graph theory, because in fact this is before graph theory, but this is the first mathematical demonstration where something that will be later called graph theory is used. And that's the problem called the bridges of Königsberg by Leonhard Euler. So you maybe know the city of Königsberg, Kaliningrad today, was built on a river, the river Pregel, if I remember right, at this time. So 18th century Prussian city at this time, and it was built on this river with different area of the city connected by bridges. And Leonhard Euler, the famous mathematician, was asked, or we don't exactly know if he was asked or if he just decided to take this situation as his main demonstration point. But the story tells that people from Königsberg at this time were wondering if it was possible to make a Sunday walk around the city by passing only once by every bridge of the city, without coming twice at the same place, without coming twice by the same bridge. So the problem could be summarized like that. Euler remarked that it's not very interesting and it's not very relevant to map all the streets of the city, but the key points that were important were the bridges, only the bridges themselves, because then you will find different ways in the different parts of the cities. So bridges were the important elements of this demonstration. And so he simplified the map of the city in a certain way, and he decided that every area of the city was a node, and every bridge was a connection between these nodes, which means that the situation can be easily simplified like that. What is interesting in this demonstration is that Euler just counts the number of neighbor of every node. So that means you just count the degree centrality, which was not the degree centrality, at least the metric was not existing at this time. But it just counts the number of bridges that connected every area of the city. And he came to the conclusion that to be possible, you can only have even number of bridges connecting every part of the city if you want to be able to make your Sunday walk. Because logically, if you arrive to an area, you will need to leave this area by another bridge, simply. Of course, if your walk is not a circle or a circular walk, you can have an odd number of bridges at your starting point and an odd number of bridges at your end point. But here, all parts of the city do have an odd number of bridges. So that means there is no possible walk around this city without crossing the same bridge twice. And so that's a very famous demonstration. And what is very interesting is that Euler is not visualizing it, but he is creating a graph metric to solve the problem. He's not doing that knowingly that he's doing that. He's not founding network analysis or graph theory, but this demonstration will be understood later as the first moment where network analysis or graph theory has been used for a mathematical demonstration. And that's very interesting to see that the metrics are at the foundation of network analysis and not the visualization. But the next example is an example that reversed that a bit. It's the example of Jacob Moreno in 1934. And this example is also the foundation of something quite important for current social network analysis, because that's the first time individuals or persons are mapped as a network. In the 19th century, we had lots of network maps that were more like traffic maps or flow maps. But it's really in 1934 that we start mapping people and relation between these people. And Jacob Moreno, I don't know if you know, or if you've done network analysis already, you probably know this example. But that's interesting. He did this experiment every teacher wants to do at the start of the year, asking all the students of the room to name the two people he wants to be seated next to. So every children in the classroom has to write the names of two other children, and then he will map the relations between these children, or at least the affinities and the friendships between the children in the classroom. And he will draw this kind of network maps, and he will do that for different years, for different school years. So that means that he will be able to understand questions like, do girls want to be seated next to other girls or to boys at certain age, or and does that change with time and so on. So social analysis. What is very interesting in Moreno's approach is the fact that he is calculating the results of this aggregation of little piece of papers from the children. He's making some stats about that, but especially he will try to classify behaviors or classify social position in these classrooms, and to say, okay, this girl is what he will call a typical leader. This boy is an isolated individual, and so on. So he will try to find some kind of patterns where we recognize in a certain classroom that there are more leaders than in another room, and things like that. So he is preparing the birth of network analysis metrics. That's his own metrics are quite interesting, especially the one that the typical leader in general, he called this person a star, not because this person is a star in the sense of a Hollywood star or someone that is very well known, but simply a star because it has lots of connections, so that makes graphically a star. So that's interesting to see that the vocabulary is just dictated by some very visual elements. And what is interesting in Moreno's perspective is that in 1934 he has no software to draw these network maps. He has to put everything on a paper in front of him. Probably he has all these little pieces of paper in front of him as well, and he will draw lines between these dots, which is what we basically do also when we are doing network analysis. And he come with something that looks like the graph on the left. You always put, and that's something you see on these kind of graphs as well. You always put the boys left and the girls right, and he always try to see the relations between boys and girls. And here I took this example because it's very visible. With this kind of layout, you see very well the relation between boys and girls here, these two edges that connect the two groups. So that means that this is probably teenagers where boys and girls don't want to sit next to each other anymore, because in the younger classes, this is something you will observe. But what is interesting is that if you take exactly the same graph and map it with a force-directed algorithm, which is simply working on the attraction between nodes that are connected together and the repulsion of the nodes that are not connecting together, you will have this kind of graph here. And what is interesting with this graph here is that we observe two different groups of women here. Blue and gray nodes are girls, and the dark one are boys. And here you see very well that there is a specific blue community here within the girls that is not more connected to the boys, two connections that to the rest of the girls with connections as well. So that means that the assumption that girls are not very well connected with boys in this classroom is not completely true, because even within the girls, they are not much connected either. Just to see that in this case, we need not only visualization to be able to comment on this graph. Of course, graph metrics could be very interesting to see local characteristics and to measure which girl is the most famous one in the classroom and which boy is the one that nobody wants to be seated next to. I don't know. But what is interesting here is that the visualization itself will modify our interpretation. If we visualize it like Moreno in 1934, we will make assumption on relations between boys and girls. If we visualize it with a modern force-directed algorithm, we'll make other assumptions. And that's something that is extremely important to take into account. We are, as a researcher, we do have the power on what we want to display on the screen or not. And that's very interesting to see, knowing that what is the use that is being made of graphs in digital humanities in general. I'm always very interested, and I'm always collecting examples from DH conferences, and here you see a few examples from recent DH conferences where in the abstracts as well, at least the authors and colleagues use this network sometimes just as an illustration, sometimes as a research tool, sometimes just to see communities, sometimes to dig into specific metrics and so on. So we have lots of different ways, and of course, what looks like applied science and very scientific method in a certain way, because it's this kind of visualization makes the paper look like it's a hard science paper. In fact, everything is in the interpretation of this output. Could be metrics or visualization. Both these outputs needs lots of interpretation. And when it comes to these graph metrics, we have so many of them that it is very hard to come with one interpretation for one metric, because it depends a lot on the data you have behind your network analysis. I'll not spend much more time on these metrics, and I will now come to the third part of this presentation. To be fair to the third part, to spend the same time on the three parts, which is now the application of network analysis to the humanities in general. I generally consider that the visualization itself can be divided into different types of uses. And I think thinking in terms of typology is not only interesting to comment on what the others are doing, but also to reflect and to think about our own practices and to think, what am I doing when I'm doing network analysis? And I'm here speaking a bit specifically about visualization, because we have seen that even if metrics are the core of graph theory and are supposed to be the tool we use mostly in this kind of research, the problem of interpretation arises specifically with visualization. So we need to discuss that a bit more. And everything I will telling here is of course based on my experience on humanities project, but of course that's something that could be understood as relevant to network analysis in general. This typology here, you see this kind of chart here where you have the type of use as columns and the type of visualization or the type of source we have behind the visualization in the vertical axis here. I make the difference between the visualization that are here for the illustration, those that are here for demonstration, interface, or research. And we can put different networks in there just to give you an idea of what I'm thinking about. But that's very, very different to speak about and to make a network visualization that is supposed to be demonstrative, to be supposed to inform the readers and the public of the structure of the subject we are working on, than working on something that is supposed to be your research object, where the layout and colors will maybe not be perfect and not be completely readable for the readers, but this visualization will be your own personal tool to dig into your subject. And this difference between demonstration and research has been used a lot in visual studies since something like 40 years now, and it's interesting also to distinguish between these different approaches or different uses. The interface visualization, where the visualization, the network visualization itself is a tool, an interactive tool to help the user to get back to the data. Of course, we do also have kind of views that are a bit less interesting, which are the illustrative views, and that's always interesting to see that we often use networks on posters or on conference websites, on book covers, and we are using also this heuristic impression of the network to make people realize that we are working on something complex. But of course, this is a bit disappointing. This is a bit deceiving, because that's not really making network analysis. It's just an illustration. I would say the real use of network analysis is within this research realm, in fact. But most of the time, when we are doing a network analysis for the first time, we don't really know, is it something that will be useful to me, or is it something that will be useful to my readers or my viewers, the public in general. And when we start, it's not always clear. And so here's the reason why I'm discussing this typology of uses, because just to be clear, that if you produce a big herbal, it's not always necessary to put that in the paper. That's not readable. That's not useful for the readers. What will be useful is probably your interpretation, and maybe this graph could be an annex, or it could be an appendix, or it could be given with the raw data on GitHub or somewhere else, to make people to give that to the people that want to go further. But that's a research tool. That's not necessarily an illustration. That's not something that will make people understand better your subject, except by showing them that, look, that's complicated. When it comes to the humanities, what is interesting is the use we make of the sources we have at our disposal to produce network analysis. So that's a very different way of cataloging or making a typology of these networks, is to distinguish the networks based on the sources, literary sources, historical sources we are working with as humanities researchers. And this typology here is just an example, or is just food for thought, especially just for us, or for each of you to think about your data and to say, okay, what am I really doing with this data? Am I trying to make with a metaphorical use of the term network analysis for my research? I mean, I don't have really network data, I don't have relational data, but I like this metaphor, and I think it is relevant to my subject to speak about interconnected people, interconnected institutions, places, and things like that. I will use that's the situation where I have no sources, and I will just produce probably no visualization, and use the network and the terminology of graph theory to describe the subject. That's the basic use of network. And then you could have, and we see that very often in the humanities, what I call the reconstituted network, where you will grab pieces from everywhere to try to have the global overview of your subject. You will grab social relations from these letters. You will grab content from these letters. You will grab or from the reports or from the books or from the newspapers. You will grab social relations from, I don't know, the birth list of the village you were working on, and so on. So you will aggregate information, you will compile information, and to try to make a network that is completely heterogeneous with the relations that are social, financial, geographical, and so on. You will put everything on the same graph to summarize your subject. So that works very well. That will probably not lead to a statistical analysis, because you cannot compare the centrality of a place with the centrality of a person. That's not the same type of data, so that's not something you will be able to work with. But as a visualization, as an interface between you and the subject, that could work very well. The next step is to extract the network from the source. So that means that you have like the list of all the members of associations you want to map, and you will take the list of all these members and just extract that from your source and translate it as a network. Or all the names that are mentioned in the newspaper for 1 year, and you will make the graph of all the names that are connected together if they appear on the same page or in the same journal article. That's the most common formal network analysis in history. You'll find lots of relations or graphs and in papers of relations between people if they sit in the same committee as someone else, and so on. And the last one is the one that I call the metadata network, where it's not a list anymore, and it's not the content of the document that is interesting anymore, but that's the fact that the documents are circulating. And that's especially the case with letter networks, where you will extract the metadata of these letters, like the sender and the recipient, and you will make a link between sender and recipient and try to understand the circulation of information. Here I represent them with I mean, probably a simpler graph that I reconstituted, a bit more complex graph that I extracted, and even more complex for the metadata network, because in general, metadata network especially are more complicated in a visual way than extracted network. But in fact, that's not regularly the case. You can have even very complex reconstituted network if you worked a very long time on your subject and you aggregated lots and lots of data. Just to give you an example of the use of these methodologies, and especially the relation between the metrics and the visualization, I will just show you a few conclusive, just one conclusive example that is based on a research I made. I could have presented probably lots of other examples, but I wanted to stay in the more theoretical realm today, and not to make the very large catalog of all colorful examples. But of course, these catalogs exist on the web, and if you're looking for inspiration, the best thing if you want to stay in the digital humanities field is to look at the abstract of the conferences, and you'll have all these colorful examples and methods. Just to so my example, my case study today for this conclusion is this committee of very well-known people in the 1920s in Geneva, which is the International Committee on Intellectual Cooperation of the League of Nations. That was my subject a few years ago. So a few scientists and experts that were gathered, put together around the table to discuss the future of universities and intellectual relations in Europe and in the world after the First World War. So on this table, you see Albert Einstein in the end, and it was really a gathering of very well-known scientists. And what is interesting to me is to analyze the documents they do have on the table, or the documents they are exchanging, because all these documents are a token of relation between them. A telegram can be sent from one to another, a letter can be written from one to two others, and so on. So these are relations between them. And if you map all the relations of these people, you will have this kind of airball. This is a medium-sized airball, I would say. It's quite smaller than the first one I showed at the very start of this presentation. But anyway, that's something that is not readable by the eye. You see here in dark blue the experts, the scientists themselves. In light blue, all the civil servants at the League of Nations, which is the ancestor of United Nations, by the way, that were supposed to work with them. And in white, attending with in white, you will see all the people that are sending and receiving letters from and to them. And of course, you will need to find strategies to analyze this kind of object, because as such, it's not telling anything. That's the archive of this committee, but you will not extract anything from this visualization. So what could be interesting, of course, is to focus on specific individuals like Albert Einstein and Marie Curie, and to compare their personal networks, of course. But what will be another way to filter this network is to try to give it some verticality, and to try to classify the people according to where they are supposed to be in the institutions, which is why we could use a multi-layer approach here, which means that we will separate the graph into different layers and trying to understand it from different perspectives and different height in a certain way. And we'll use this in the metadata network to map these relations between the people. We will use some affiliation networks to map the relation between people and the institutions. And we will use the map of the institutions, or the organigram of the institutions, to arrange all these organizations and people together. Sounds a bit complicated, but in the end, this means regrouping people on this two-dimensional space to try to make sense of their position relative to each other. And here you see very well that this committee of scientists in dark blue, they are all together at the same place now. All the civil servants are all at the same place, and now you can see the graph unfold on this kind of organization chart, and you will be able to compare, like for Einstein and Marie Curie, if they have more relation towards outside or inside, and especially to see that here Marie Curie is much better connected to the outside than Albert Einstein, for example, and so on. And what will be very interesting is to play with the metrics, because we do here we are here able to read a few things, but of course graph metrics linked to this reorganization of the graph will be very interesting, especially if you are now able to classify these individuals according to this vertical hierarchy, and to see that, for example, the civil servants are way better connected than the member of the committee itself. So here you see the civil servants in light blue and the committee in dark blue, and you see very well that the committee has a very high weighted degree centrality, which means they have lots of connections, but the civil servants have a much bigger betweenness centrality, which is the metric that indicates that there are more bridges between different communities. And that's very interesting as an historian to be able to know that even if the experts and the scientific Nobel Prizes and famous people do have lots of connections, they don't have the connections that makes the information circulate, really. Thank you for your attention. I'm looking forward to discussing with you for a few minutes now. Yeah, we have.
Thank you, Martin, for the exhaustive presentation on network analysis and its uses. So let us all thank you, and we are uploading both here and digitally on Zoom. I have several questions as a long-time network enthusiast, but first I would like to ask the audience, either Zoom or here, for questions. Вопросы? Yes,
Excuse me, can I ask a question?
Okay,
let's
take one. let's take one from the audience first, because it was first, and then one from the Zoom, right? Okay, now audience.
Ladies first.
Okay, the audience gives the priority to the Zoom, so Anna.
Okay, so the question is, well, that's actually a question connecting your presentation to some previous lectures we already heard. Do you think that it makes sense to do a network analysis not between people, but also between people and, for example, objects or data sets or other, you know, other virtual or physical objects that exist, to see, you know, how to see their relationships?
Yes, of course. I think you should probably go into that direction, because, well, of course, I don't see your data and globally and more precisely your research question. The thing we have to keep in mind is the fact that if the network has more than one type of nodes, which is more than just people or just data sets or I don't know what, the graph metrics will not be very helpful to put your finger on the places that are interesting for you or not, if it's a big graph, because they will be skewed by the fact that I don't know, lots of elements of type 2 will be connected with a few elements of type 1 and so on. But that does not mean that you should not do that. In fact, what we generally do is to project the graph, to make a projection from a 2 mode to 1 mode. So that means that, yeah, you anyway, any graph is interesting per se, and then let's see which strategy we need to construct around it to analyze it.
So basically, what you're saying, the research question should be very specific. If we are having, if we have different elements and different categories of nodes, I would say the question should be very specific. So the information we don't need would not appear. Something like that, right?
In a certain way, yeah, your research will have 2 steps on this data set. The first one is the one where you have everything and you try to gather everything and to put everything at the same place to be able to have your global overview, and then to have specific questions exactly to be able to filter this graph and to say, okay, now I want to see only the people or only the data sets or only the documents or only the concepts, I don't know, so that you can really focus then on something more precise depending on your question. Yeah, because it's very hard to ask the right question when you have a very heterogeneous field in front of you.
Exactly. Thank you.
Thanks a lot. And now let's take a question from the audience, from Leonid Osevich.
Yeah. Thank you for your interesting paper. And my question is to some extent continuation previous question. What was my question concerns possible linkages, possible networks, not between the persons, but between, say, groups of persons, or for instance, if we study migration flows, the structure of these migrations between different regions could be represented as a network. So it's not the links between people, between, let's say, persons. Or for instance, if we study the commerce network between some countries which are in trade, so on. So is it normal when you study networks based on the relationship between persons? Am I right supposing that about 90% of all networks in the humanities, which you know, they concern networks between persons? Or it's not so?
Thank you so much for this very interesting question, and I feel that it is rooted in question you do have in your research, and that's nice to hear. You're right that most of social network analysis are done on persons, because that's a discipline that has emerged from the social sciences in the 1950s, and it was so that social sciences in general analyze people, and so that's why it developed around these kind of questions. But of course, that's not the only type of relations you can analyze. And what is very interesting is that commercial and migration flows have been analyzed already in 19th centuries as not necessarily exactly networks, but maps with this kind of big colorful flows. And that's really the ancestor of this kind of geographical network analysis. And that's something that can be completely done at the regional or state level. Of course, that will be quite easy, but what will be interesting is, of course, to go just a bit lower the regional or state level, but to see it with a bigger number of geographical entities, so that you have a very precise view of these migrations or financial or commercial flows. Of course, this kind of data in general is not available at the personal level, because you don't have exactly personally every people that is migrating from a place to another. In general, the statistics are aggregated statistics, so that means that you will have to analyze them at the global level. What would be interesting is to have this kind of multi-layered perspective, where you can go from the very personal and individual level to this aggregated level, and some tools could help to do that, and so to be able to develop our interpretation not only on big pictures but also on very small individual stories. I would say that's a very interesting field.
Thank you. May I ask one more question? The question is, I have some hypothesis that 90% of all cases of usage of network analysis, they give just visualization of this network, and only small part of these publications really use the graph theory. Some concepts and notions from graph theory. Is it true?
It is probably true in the humanities. Yeah, in the humanities.
Yeah, I mean humanities, of course.
Yeah, because it won't be true probably for other disciplines. But the thing is that in the humanities we have a quite short history of using network analysis, and I think that's part of the explanation. We are for the moment still in the moment where we are amazed by these pictures, and we need to go beyond that. I didn't want it to be too technical about going beyond that today, because probably some of you discovered network analysis recently, or were not very familiar with or the graph theory. But that's true. We have this kind of bias in the humanities where we do love pictures, and we love analyzing pictures, and we when we produce the picture, we just speak about the picture, and then we don't go beyond that.
Thank you. Yes, I understand.
Yeah, Martin, thanks a lot. And I think we ran out of time for more questions, although I had several. So let us thank you again for the presentation, and we'll move on with the conference. So yeah, it was really an entertaining and great talk.
Thank you so much for having me. Have a nice conference here in Krasnoyarsk and online.
Many thanks.